All right, hello. Cheers, Kevin here, and welcome back to Minecraft Agoraphobia. And I am very excited to announce that I think I finally have pretty close to a full set of armor and tools. So we have a diamond helmet with mending, protection, unbreaking, aqua affinity, respiration, a chest plate with mending, unbreaking, protection 4, and thorns 3. Protection 4, mending, unbreaking legs. Protection 4, unbreaking 3, mending, feather falling, depth strider, boots. We have a sword with we have a sword with sharpness 5, sweeping edge 3, unbreaking 3, mending, looting 3, knockback 1. A big axe with efficiency 5, unbreaking 3, fortune 3, mending. All of these have mending, basically. We even have a mending, unbreaking hoe. I suppose that's technically important. And then we have a silk touch pickaxe just as our backup that also has mending on it, and our wonderful luck of the sea lure 3, mending and unbreaking 3 fishing rod, which has powered pretty much the entirety of this adventure of getting ourselves geared up and enchanted. So it's been a long time trying to gather up the levels, though, even with the AFK fishing, because it takes a long time. But of course, that's not why we're here today. We are here to visit our robot and see what we've been working on. So yeah, I don't know why I'm going up here. Yeah, we'll have to eventually. Ooh, that's fancy. Uh-huh. I wonder if I can. Yeah, I can't shoot through there, but we are going to head downstairs and take a look. I have gone ahead and redone our sheep farm once again. I am keeping an eye out every time I come down here because tend to spawn a fair bit of Enderman. Kind of every single time I come back, there's an Enderman or two, which is great actually, because some of the recipes call for Eyes of Ender, and of course they have been brutalizing the cactus farm, which is unfortunate. But once we have Eyes of Ender, we can create things like internet cards, linked cards, and other fancy things that we may eventually want. So as much as I'd love to not have them destroying my base all the time, they're not the worst things in the world either. Okay, so let's take a look at the new setup. I've kind of moved the actual base of the farm out here into the middle. I still need to migrate some of these things out of here and put down some more carpeted capacitors, because this is now 5 by 6. The reason for that is that, hey, our system for keeping these sheep in here before was way too complicated. It was over-engineered. We didn't need anything like that. We can basically use the same strategy as you'll see in modern villager breeders, where you basically just have them stand on top of a fence, or in this case, an iron gate, and they'll go ahead and spawn. So actually, do we have... Oh, no, I've got 2 wheat. Do we have any more? We've got some more somewhere. Still need to sort out and clean up all this stuff. All right, well, we've got the 2 at least. Let me check in here and just see. No, okay, fine. Well, let's go ahead and just feed these folks up. Feed 2 of them, and we'll step back and watch. They breed, and out pops a little baby sheep. So that is now, in theory, a sustainable thing. We don't have a way to stop them from dropping out. I suppose we could use some sort of block swapping thing with pistons if we really wanted to, so that we could breed up this top section. But in theory, these things should not despawn, and so we shouldn't have to worry about it. But what I want to do today is take a look at our robot. And I discovered, kind of in future research, we had, where do we put it? We had some upgrades. Yeah, we had this inventory controller upgrade, and we had this crafting upgrade that we wanted to install in this robot, but we couldn't, and it was very sad and depressing. The reason we weren't able to do that is because if you look at the colors of these tooltips, they are yellow. That signifies that it belongs to a tier 2. It is a tier 2 upgrade, and the tier 1 computer case does not support tier 1. It does not support tier 2 upgrades. We would need to use a tier 2 computer case. So we need a fancier robot to do things like craft or swap out and what is in the equipment slot, which is kind of unfortunate because I really wanted to get this thing able to go up here, feed these sheep some wheat, and then pop back down, get some more wheat, go up there, feed these things some wheat, and kind of do that indefinitely, because that's what we need to get our renewable power really working, is to just kind of perpetually feed the sheep so that we don't have to worry about it. Of course, then we do actually have to renew the wheat, but that's a step away. I'm going to grab a stack of... I'm going to grab a stack of wheat real quick, just because... we're gonna start actually writing some programs today and like to test. I was hoping also there'd be some way for me to test my fancy sword. Suppose, there you go, look at that. All right, One hit wonder. Okay, let me grab some wheat and I will be right back. So let's go ahead and throw the wheat in here, and I'm gonna go ahead and power this on. Now, of course, it is sitting right on top of our charger, which is great. One thing that I do want to do, though, is I would like to move our charger and whatnot over to, well, probably over here. I think we'll probably plan on building a little charging station down there. Although, actually, I want to dig out, because I'd like to run this cabling a little bit lower if I can get away with it. And it looks like I can. Perfect. Okay. Do I have power cables in my inventory? I do not. All right. What am I thinking? Let's pop this up over here. And then can we dig out? Yes, perfect. Okay. So we can actually run kind of in amongst this bedrock to get out to here. And that's perfect, because I'd like to get this this charger set up on this square so that it's flush with the ground, and that would be ideal. So let's go ahead and actually make some more cabling. I think I need some iron for that. Where do we have? I know I've got iron somewhere. There we go. Let's get some stuff out of our inventory. Lapis, and yeah, okay. Let's make some more cable. Oh no, I need iron nuggets. Chicken nuggets. All right. All right, that should be more than enough cable. We're wasting iron away. All right, sounds good. Let's get back down here. Woo, so fast. I love it. Okay. And then there. So that now means that we do have connection to this farm. And we'll dig there, and perfect. So now we can actually cover this up, so we don't have to worry about kind of hiding stuff. Cover that up, and then I'll plop that down. Okay. There we go. And plop that down, and I will put the charger there. So if we... How are you doing? Okay, yeah, so this is up. In the meantime... Oh, most blocks act as cables. BT dub. There are relays and power distributors that we may want to use at some point. The reason for that is that if you have the cables connected between things, well then your computer may decide, hey, there's a monitor in the other room. I'm going to assume that that's not my primary display, and things like that. So you can use these distributors to make sure the power still goes through, but sort of the data signal does not. Okay, Future Kevin jumping in here real quick to let you know, we spent a bunch of time at the beginning of the video trying to figure out how to get files to run on startup. I do think I figured out how it's supposed to happen, but it's honestly not something that we really need right now, and so I ended up deciding to cut it out of the full video. We're going to jump back into actually writing a script that does something rather than trying to make sure that it executes on boot. Because by the time we actually do want things to run on boot, well, then we can actually install that as a separate BIOS and put those in drones and all sorts of fancy stuff that we'll get into in future episodes. But just explaining why there's a little bit of gap, and so if you notice some continuity things, that's why. We cut out a whole bunch of stupid time exploring how this open computer system works. Cheers. And now, well, we've got some coding to do. All right. But before we actually do that, I'm actually going to take this out. Let's go ahead and move you to your starting position. Oh, my inventory is full. Fair enough. So many books. All right. Let's come over here. Let's drop off some diamonds. Okay. We'll plop you down. Right on there. Oh, that's another thing I forgot. Want to do. Oh, hang on. No, I did not think this all the way through. Yeah, I don't want the cables to run exactly where I put them. I would like the cable to run here and here, because that means that under here, I can put a redstone torch, which will provide power to this charger and ensure that it stays on. So we don't have to have a lever on the side of it. Let's grab that, throw that up there, make ourselves a torch. Very complex stuff here. Okay. That goes there, and boom. And now this is on, and we can go ahead and cover that thing up. Perfect. All right, there, and boom. So now this thing is on. We can put this back down, and this thing is going to continue to regain power over time. So that's great news. So what we have to do is write the program that's going to go up here, try and feed the sheep, and then just come back. So we've got this. Now we did see that we were able to use the use command. Use. Okay, we are off right now, so let's turn on edit sheep farm Lua. Okay, so our coding to do. First thing we need to do is go up a certain amount of times. Let's count. So we want to 1, 2, 3, 4 times. Actually, let's. If you're going to be facing that way. Actually, so the one thing that I did notice is that eventually when we upgrade to something that can manage its inventory, for whatever reason, they're only allowed to move things out of chests that are in front of or behind them. So I'm actually going to, before we start writing this at all, I'm going to go into Lua. I'm going to say robot dot turn right. So the robot is going to be facing. What? Let's do that again. Oh. I didn't call the function, I just returned the function. So the robot is going to face this way so that eventually it can access this chest once we have an upgraded version of the robot that can do exactly that. In the meantime, it'll be our job to simply replenish the store. So we want to run robot.up 4 times, 2, 3, 4, and then over 1, 2, 3, 4 times, I think, and let's... test. Oops. Yeah, there we go. Edit our sheep farm. Let's remove the hello script so I can use tab complete safely. And edit hello script. And sheep farm. And we're going to be lazy. Well, actually, no, we can use loops. So we can say for I equals 1, 4. And this will loop over something 4 times, with I being a value that will equal 1 and 2 and 3 and 4, depending on which time we're calling it. We'll just say robot dot, what was it? Just robot dot up? Is that really it? Let's do robot dot up, and then let's do the reverse as well. For I equals 1 to 4, robot dot down, and then end. And yeah, let's try running that. And to run things, we can just say sheep farm, like that. And of course it gives us an error. Do expect it. Okay, yeah, my syntax was wrong. This is the problem with not doing a ton of Lua. For that, do. So we need do and end as the ways that we kind of dictate the edges of our block. So this is going to go up by 4, and that's going to come down by 4. So that's great news. Then we're going to move over to the left by 4. You can see also I've exposed the exposed some stuff there, but that's okay. Robot up 4. And then we'll do another for I equals 1 to 4, do robot dot left. Does that work? Let me see. Let's see, Lua. Robot dot left. No, okay, I don't think we can actually, I don't think we can translate to the left or right. So we'll actually have to turn. That's fine. Let's go back into edit. Okay, so we will then robot dot turn left. And then robot.forward. Okay, so this is the go to the sheep. You use 2 dashes for comments, and then come back. Okay, we go. So there we go. We're now in theory over the sheep. There are 2 squares that are over the sheep because we made this too wide. You can put them in a 1x1 area, but then the sheep don't have much room to move, and it's very likely that we end up kind of hitting the same sheep over and over and then can't end up feeding them. So that's a bummer. Okay, so we've got there. We go forward. Let's say robot.turn around, and then for I equals 1 to 4, do robot.forward and end. So now it's facing this way. We go down, and then robot.turn left. Wait a second. Turn left, turned around, turn left. Yes, okay. Let's try that. Who knows? Let's watch. It goes up, it turns, it goes over there. It's over the sheep, it turns around, it comes back, it comes down, and then turns back to face the chest. Fantastic. Okay, good job, Amelia. Now we actually have to do the feeding part. So let's get that set up. Do the feeding. Let's try. I want to try and feed a couple of times because, you know, the sheep are moving around. We want to make sure we're feeding different ones and stuff. We're never going to get perfect coverage, but that's okay as long as we get some. So let's say for I equals 1 to 10. So 10 times we're going to try and do some stuff. We're going to say robot dot, I think it's use down. Because, yeah, we used use to just do the thing, hit the thing in front of us, but use down is going to attack below us. It's going to use whatever is in its tool slot, which in this case is wheat. It's going to use down. But I want to do something. So we're going to go back and forth between those two squares. So we had the first square. So we'll try hitting down. Then we'll say robot.forward. Then we'll say robot.use down. And then we'll say robot, tab complete, dot back. Is back the command? Let's check. Robot.back. Yes, okay. That's right. And this does mean that we'll be back in the same starting position once we're done with this loop. So we're just going back and forth 10 times, trying to feed here, trying to feed there, trying to feed here, trying to feed there. And hopefully that'll do some stuff. So let's go ahead and save that and quit. And then hello sheep. Going over there. Feed. Yay, hearts. Yay, they're breeding. Look at that. All right, so we're failing to hit a lot of the time, but that's okay. We're not going to use up the wheat if we miss, and we did make a baby. So that's fantastic news. All right. This script seems to be doing exactly what we might like. Okay, I have no idea how much of the prior clips are getting cut out here, but the summary is that we have disassembled our robot, upgraded some of the components, including unrecoverable error, no such component. Huh. Oh, this screen is just displaying what it last had. We're booting that up. We have reassembled this with a better case and better, a bunch of new stuff. And so now it's named Kodos because it just gives it a name, I guess, from the assembler, and that's great. We don't have anything installed on the hard drive yet, but that's okay because it has a disk drive, which is great news. So let's go ahead and plop Kodos down. Plop you down. There you go. All right, you're facing that way. And yeah, there's a spot for this. And now it does have, and we can throw in the experience upgrade. Hooray! All right, let's go ahead and turn this on. I guess we can, sure, let's throw the wheat in here. Now, the wheat, I should say. We're going to have to install onto the hard drive, but it does at least, it's boot. Oh, right. Yeah, it's booting off of the floppy. Because of the noise. All right, there we go. Let's go ahead and install. Install OpenOS. Yes. And it's going to go ahead and start installing that to hard drive so that we can take that disk out. Meanwhile, over here. Right. I put the old hard drive that had been in our previous robot in here because I want to copy the program that we wrote and put it onto a blank floppy disk. So that way we can go ahead and toss that in here because otherwise we don't have an easy way to transfer that. So let's say list. Yeah, package robot is not, module robot is not found. Low memory systems. Okay, list. List in tasks. Yeah, so it's complained on boot up because it was saying, hey, I am not able to require a robot because it's not a robot, which makes sense. Let's connect. If I could type mount, is this going to show? Let's see, /template. There's a command called label, and I think 6F4 is, actually we can see. Yeah, 6F4 is the device. Okay, let's plop that back in there. Let's see, can I label? Let's look at the usage. Label. MNT. Well, no, let's not even bother. It's already mounted, so we don't have to worry about that. Let's just copy tasks sheep and copy that onto mount 6F4 sheep.lua. So this is going to copy it to the disk. And can we unmount a thing? No. Oh wait, it does. It is a thing, I think. 6F4. Cool. Now if we list what's mounted, Yeah, the disc is not mounted, so we have ejected it effectively. I don't know if we need to do that. Back in the olden days, if you didn't unmount, so, I mean, it's just like with. Oh yes, go ahead and reboot, please. Let's take this out. And there we go. Okay, so now this will boot without a floppy disk. And now this is fancier. Okay, if we put in this floppy disk, we should be able to. I'm going to go ahead and make dir tasks. And we're just going to copy the same old script that we had been working with that goes up, goes over there, and feeds our people. So let's see. If we mount this, should have automatically mounted, and it did. Okay. So 6F4, so copy MNT 6F4, whoops, 6F4 tasks. No, not tasks, sheep. There we go, and copy that into tasks. And now we should be able to get this back to where it was before. Let's edit tasks sheep.lua. And yes, this is requires robot, requires computer. Turns off the computer, except now we don't particularly need to do that, do we? I mean, well, we can for now. So what we want to do, well, let's run it and make sure this still works. Actually, no, I'm going to go ahead and say we're going to put the wheat in here, and let's open up Lua, and I'm going to say robot.equip, except nope, that's not what it is. So if we require the component and then say inventory manager. No, that's not the right thing. Let me look it up. It is inventory controller. And that is a thing. So inventory control, let's say controller equals that. We'll say controller.equip. Oops. Missed a letter there. And boom. So now the robot has been able to grab this thing. Okay, so now let's add a step. We're going to put this in the chest. And I'm going to say controller suck from slot. And I know it's a weird term, but this is the way that you transfer items from external inventories using this inventory controller system. Now, it can only do it from forward, which is weird, but that's okay. Now, we need to give it this. I forget the API. Does it give us the? Yes, it does. Oh, perfect. So we need to give it which direction it should suck from, what slot number, optionally the count, and then it's just going to plop it into whatever the selected inventory slot is. So if we give a controller suck from slot, and if we happen to have memorized the numbers for the sides, because it says, well, forward is 1 and up is 2, or what, those aren't accurate, but whatever it happens to be, then we can do that. Otherwise, we can just say require sides, not front. So we'll say take something from the front in slot 1. No inventory. What? Why? But it's right there. Oh, because we're facing the wrong way. Robot.turn right. Okay, so now if we try that again, there we go. Now we've popped it, and now we can say controller.equip. Yay. Now a question, if we do something like that, can we... So this seems to toggle, that does not work entirely as one might expect. Let's see if there's any additional documentation. No, okay, fair enough. I mean, that's fine. So I'm gonna take this away and put it in here, and let's update our script now. If we not exit. Edit tasks, sheep. And we're gonna go ahead and say local controller equals require component inventory controller. And unfortunately, I'm bummed that that's multi-line, but whatever. So first thing we've got to do is grab the stuff. So we'll say grab the wheat. And so we'll say controller suck from slot. Let's put sides up here too. Local sides equals require sides dot front. And so then we will suck from slot sides front. Oh, sorry, no. we just require sides. Sides, front, and from slot 1. And I think we can give it 64 as the argument. I mean, I don't think it matters. I think we'll just take everything that we can. And then I think we can, there are also methods that we can do to sort of inspect what is in the chest. So we could look at all of the slots in the chest and possibly get everything that way. That's another option, but whatever, this is fine. We'll say controller.equip. And now we have the wheat in our hand. So that means at the end, if we're going to make this something that we can just do repeatedly, we'll say put the wheat back. Yeah, I mean, this will get messy if somebody else starts manipulating the chest in the interim. But I suppose we can at least just top off the one slot in the chest without anything breaking. I think, actually, yeah, we're going to have to test this. I think equip will also unequip, but we'll have to verify that. I don't remember the syntax for put the thing in the slot. Let's see if we can find that out. We don't have memory. I can't hit up and remember things. Okay. Controller equals require component inventory controller. Controller dot put. No. Equip our stacks equivalent, get stock slot stack size, compare stacks, drop into slot. I think that's what we're going to want. Oops. Give me the information. The facing slot number. Perfect. Drop the selected item stack into the specified slot in the inventory. That's exactly what we want. Let's edit our tasks again. And controller dot drop into slot and sides dot front. 1 and then everything. So this now is something that is in theory repeatable. So I'm going to go ahead and do while true. And sorry, it's while true do. And in theory, I could indent everything in here, but I'm lazy. Let's go ahead and end. And the only thing that I also want to do in here is I actually would like to wait for a little bit. It looks like there's something in the library that will do that. So we'll say local OS equals require OS. And then here we'll say os.sleep for, I'm going to say let's sleep for 30 seconds. Another thing that I'd like to do is when we're actually doing the feeding, let's see, use down, go forward. Let's see. Yeah, I'd like to add an os.sleep 5 seconds there. And hopefully this works. We can give it a test. Now, this is not going to ever end, I think. Tasks, sheep. I mean, unless it's broken, we'll see. All right, it pulled that. It's in its inventory, or it's equipped it. Goes over there. It's going to wait a second. It's going to wait 5 seconds for 5. And it goes over there and does another one. So it is trying to let the sheep move around and cycle around a little bit. And it is going to do this 10 times. Then it's going to come back here, wait for 30 seconds. And I guess we can get a glimpse of what its charge looks like when it gets back here. But I think this is enough to kind of get us going. The only thing we have to make sure to do is, I guess we'll have to build another robot that does some harvesting of wheat and throws it into this chest. And after that, we should be theoretically self-sufficient. So I think this is going to do this 10 times. I'll hop back as soon as it's on its way back. Okay, there we go. Coming down. How are you doing, Kodos? Oh yeah, you're still at like 100% energy. And you're in theory now waiting. You have put, yeah, so you've put the wheat back. That's great. What happens now if I take all this out? Oh, actually, I probably don't want to try that. I probably don't want to try that at all. Because I'm worried that use is going to end up meaning punch sheep with your fists, and I don't want to discover how that ends. There we go. Okay, so it is going on its second feed cycle. And that is fantastic news. Okay, so I think I am going to continue to work on this script a little bit over the weekend. We'll see what sort of improvements we can make. Another thing that will be interesting is to possibly make a little drone that can do that. Although to make that work, we're going to need to compress everything so that it will fit on one of these little EEPROMs, and I think that's limited to 4 kilobytes. Drones don't have hard drives and whatnot. They run entirely off of these EEPROMs. So we're going to have to see if, and the libraries as well, that we're doing these whole require statements and stuff, those have to be factored into that number. So we're going to have to see how feasible it is. But I'm excited. I hope you're excited as well. Let me know what you think in the comments. I'm looking forward to your feedback and definitely point out ways that I've been stupid. But as I said, not mainly a Lua person, but very excited to be doing all of this. So I'm just trying to get a lovely thumbnail shot here. There we go. And yeah, I think that's going to do it for us today. I hope you have a great weekend, and I will see you next time. Cheers.